Know-how of the universe. These pics found out a worrying fact. Our present-day physical expertise isn't always enough to explain the character of the cosmos in its early ranges, wherein the huge bang concept reaches its limits. This forces us to keep in mind new hypotheses about its beginning. The question arises as to how the universe changed into fashioned an element and why this new discovery assignment is even the most experienced astronomers to discover more approximately the Big Bang and the progressive info of the discovery. Let's take into account the idea of the huge bang itself. Contrary to common perception, the massive bang became not an explosion in pre-existing space. Rather, it became area itself that originated approximately 13.8 billion years in the past, in conjunction with rely and time, from an authentic singularity. In physics and astronomy, a singularity describes places where gravity is so excessive that the curvature of spacetime will become countless. Today, after billions of years since the start of the universe, we find that our cosmic home is part of an essential technique for specialists. This represents an intrinsic characteristic of the universe since its very life. It is apparently limitless expansion. However, it's vital to keep in mind that the cosmos is not increasing into pre-existing space. Instead, space itself is constantly growing. In accordance to conventional theories, the first stars began to polish between 200 and 300 million years after the massive bang, marking the quit of the so-called Dark Age. This became whilst the first luminous celestial objects clustered together to form mature galaxies. But how speedy those galaxies grew remains an unsolved enigma. An crucial clue emerged through the primary pics captured via the James Webb Space Telescope. In July 2022, specialists announced that the telescope had detected some of galaxies, a number of which had already existed a few 300 million years after the formation of the universe. However, as compared to the galactic structures that evolved millions of years later, those early galaxies remained substantially smaller and much less massive. This suits perfectly with the scientific model well known via researchers. The density of B counted in the younger universe turned into absolutely now no longer sufficient to give upward thrust to galaxies the dimensions of those discovered these days. What started out because the discovery of 6 vibrant, redshift luminous spots from James Webb became out to trigger one of the most extensive astronomical crises of current instances. Although those newly determined galaxies are comparable in age to previously recorded galaxies, they are almost as massive as our very own Milky Way galaxy. This has created an interesting mystery in astronomical research. After examining a series of pics captured via the near-infrared camera, professionals identified the previously mentioned mild resources. Using redshift, scientists calculated that the mild from these objects took extra than 13 billion years to attain our eyes on Earth. Consequently, we're handling systems that had already existed among 5,700 million years after the alleged massive bang. By studying the traits of these structures, it was concluded that the James Webb Telescope had captured 6 extremely early galaxies within the photo. Notably, these galaxies were so large that they defied conventional expectancies of cosmology. Rather than locating the anticipated dwarf galaxies, structures have been recognized that were nearly as big as our personal Milky Way galaxy despite having formed early inside the epoch. If we hold to analyze the data collected via the James Webb Telescope, this gravitationally certain grouping of stars was already more than 10 billion instances the mass of the solar at that point, with one potentially surpassing the 10 billion solar mass mark. However, even though this opportunity is considered, the thriller is not absolutely solved. Even in this situation, there might be drastically more stellar mass in the early universe than previously assumed, posing a puzzle. The detected gadgets contradict definitely all conventional cosmological theories. Even if handiest one of these galaxies turns out to be actual, it could venture our preceding assumptions to give an explanation for the life of those systems. Moreover, the density of remember inside the early cosmos could have needed to be as much as 5 instances more than previously assumed to give an explanation for this phenomenon. Another equally mysterious clarification is based at the reality that those galaxies evolved in a way that is still absolutely unknown to us. These discoveries and the debates surrounding the huge bang are main more researchers to move away from this principle. Many astronomers with alternative perspectives are pissed off that they're no longer being heard in medical journals. Even folks that express doubts about existing theories are often categorized as unfounded eccentrics. But it's far undeniable that even experts who nonetheless shield the huge bang idea are constantly faced with questions without clear answers. These questions consist of precise issues, such as why and the way 13.8 billion years ago, did something literally come out of nothing? Can something virtually originate from nothing, or become there some triggering event, or turned into all of it just a twist of fate? Stephen Hawking talked about that the concept of time as we understand it began simplest with the huge bang. Therefore, this method couldn't have been prompted by way of something else or a person outside. A comparable debatable question pertains to the uniformity of radiation and density at some point of the cosmos. No matter in which dire route or at what distance we appearance on a bigger cosmic scale, we find similar densities and distributions of galaxies, nebulae, and radiation everywhere. Conservative scientists give an explanation for this phenomenon by using the concept of cosmic inflation. But different professionals take this assumption in addition with a principle of chaotic inflation. According to this concept, it's possible that inflation has most effective stopped in a few areas, like bubbles, and maintains infinitely somewhere else. This implies that more than one universes form in these bubbles, each with its very own individual bodily legal guidelines. Inside this model, an essential question arises: what if the cosmos does no longer represent the complete entire? Or even extra, what if some other universe existed earlier than ours? In that case, the huge bang would end up a part of a larger cycle. According to this angle, our universe is part of a larger, multidimensional structure. Inside this model, the idea of an everlasting cycle of collapse and rebirth of the universe is positioned forth. But this isn't always the only angle provided inside the field of cosmology. Apart from the huge bang concept in 1955 as an instance, an editorial appeared in NASA's Cosmic Times arguing that there may additionally have never been a huge bang, because the universe has existed for an infinite time. In this view, the enlargement of the cosmos would be non-existent, and the continuous formation of remember ought to provide the impression of a steady enlargement of the universe. Another interesting though controversial principle comes from the world of quantum physics and string theory. Supposedly, a few experiments have advised that our universe and everything in it do not sincerely exist. In simple phrases, what we understand as the visible universe should virtually be a flat hologram projected onto a sphere. Therefore, there may be a possibility that our truth is a result of a higher simulation. Even as this may sound like the plot of a whimsical technology fiction film, it is able to be connected to the Kardashev scale, which measures the extent of development of a civilization in keeping with its ability to use energy. If there had been a kind 3 civilization able to absolutely harnessing the electricity of an entire galaxy, it could have created a really perfect simulation. But locating out the reality in this sort of state of affairs is a totally complex count number. Exploring the depths of cosmology and the origins of our universe leads us right into a realm of profound mystery and ongoing scientific inquiry. The current snapshots captured by means of the James Webb Space Telescope have reignited discussions about the very fabric of our lifestyles, calling established theories and prompting scientists to reconsider essential factors of cosmological knowledge. At the coronary heart of this inquiry lies the huge bang principle, a cornerstone of modern cosmology. According to this idea, approximately 13.8 billion years ago, the universe emerged from an unimaginably dense and warm country, expanding swiftly and giving upward thrust to spacetime and matter as we recognize it nowadays. This cataclysmic event isn't always merely an explosion within pre-existing area, but NBS, the very foundation of area itself. The concept of a singularity, wherein gravitational forces are so intense that spacetime curvature becomes endless, underpins our expertise of this primordial epoch. Yet the invention of early galaxies by means of the James Webb Telescope demanding situations are assumptions approximately how fast shape fashioned in the universe's infancy. Those galaxies detected within some 100 million years of the huge bang seem exceptionally mature and big, opposite to expectations based totally on cutting-edge cosmological fashions. One of the fundamental questions raised by means of those discoveries is the character of cosmic inflation. In step with the triumphing theory, inflation befell inside fractions of a second after the large bang, inflicting the universe to amplify exponentially. This rapid enlargement could give an explanation for the uniformity of the cosmic microwave background radiation determined throughout the universe nowadays. However, the current findings endorse complexities in the early universe's evolution, which could require revisions to inflationary fashions. The formation of galaxies, including those discovered by means of the James Webb Telescope, challenges cosmologists to reconsider the situations and techniques that ruled the universe's early epochs. Those galaxies already large in size and mass so soon after the huge bang suggest a density of count number that surpasses previous estimates. The puzzle deepens whilst thinking about how such massive systems could form and evolve in an exceedingly quick span of cosmic time. Furthermore, the invention of those early galaxies increases interesting questions about the nature of darkish rely on and darkish electricity, elusive additives that make up most of the people of the universe's mass-energy content. While dark depend is idea to offer the gravitational scaffolding necessary for galaxy formation, the distribution and properties of dark matter within the early universe remain unsure. In parallel to these astrophysical mysteries, theoretical physicists are exploring alternative models of cosmology that undertaking the traditional huge bang paradigm. A few theories suggest that our universe is simply one of many in an enormous multiverse, each with its very own specific physical laws and constants. These thoughts, stemming from tendencies in string concept and quantum cosmology, suggest an extra complex and interconnected cosmos than previously imagined. One concept gaining traction is everlasting inflation, wherein universes emerge continuously from a bigger inflating space. This idea posits that our universe can be just one bubble amongst infinite others, every with its very own wonderful residences. The mission lies in finding observational evidence to support such speculative thoughts as they push the boundaries of empirical verification. Another provocative hypothesis is that our universe exists inside a simulated reality, comparable to a computer-generated simulation. This concept draws parallels to improvements in artificial intelligence and computational science, in which simulations can replicate complex structures with marvelous constancy. If proper, our perception of truth as a tangible physical universe might be fundamentally altered, elevating profound philosophical and medical questions approximately the character of existence. Furthermore, advances in observational astronomy continue to reveal the universe's vastness and complexity. Telescopes like the James Webb Space Telescope, with its unprecedented sensitivity and resolution, promise to unveil even greater secrets and techniques of the cosmos. Future observations may also shed light at the earliest moments of the universe, offering clues to its final destiny and the underlying ideas that govern its evolution. Beyond observational astronomy, particle physicists are exploring the essential debris and forces that form the universe. The hunt to unify gravity with the opposite three essential forces, electromagnetism, robust nuclear pressure, and vulnerable nuclear force, stays a primary purpose of theoretical physics. Theories such as quantum gravity and string principle provide capacity frameworks for expertise those fundamental interactions at both the smallest and biggest scales of the universe. Inside the realm of quantum mechanics, the character of time itself remains a subject of intense debate. The concept of time as a linear progression from past to future is challenged by using quantum theories that advise time can be emergent or maybe illusory at the fundamental degree of information. The nature of time inside the context of cosmological fashions should revolutionize our expertise of the universe's beginning, place, and evolution. Furthermore, the search for extraterrestrial lifestyles maintains to captivate the public imagination and drive medical inquiry. The invention of exoplanets, planets orbiting stars beyond our solar system, has improved our information of planetary range and the capacity for habitable environments elsewhere in the universe. Future missions, which include the James Webb Space Telescope study of exoplanet atmospheres, may also provide proof of biosignatures indicative of existence beyond Earth. Further to those medical endeavors, cultural and philosophical reflections on the cosmos enhance our information of our place in the universe. Questions about that means of life, the possibility of shrewd life someplace else, and humanity's future in space exploration inspire contemplation and debate throughout disciplines. As we stand on the brink of a brand new technology in astrophysics and cosmology, fueled by using technological advancements and theoretical breakthroughs, we are reminded of the profound interconnectedness of all matters. From the smallest subatomic particles to the full-size cosmic structures spanning billions of light years, the universe reveals its mysteries to those willing to discover and question. In conclusion, the exploration of the cosmos and the origins of the universe is the adventure that transcends disciplinary limitations and demanding situations our maximum essential assumptions approximately reality. The discoveries made through contraptions like the James Webb Space Telescope provide tantalizing glimpses into the early universe and provoke new questions about its formation and evolution. As we hold to get to the bottom of the mysteries of dark electricity, and cosmic inflation, we inch in the direction of a more comprehensive understanding of the cosmos and our region inside it. Via collaboration among astronomers, physicists, philosophers, and technologists, we embark on a collective quest to decipher the cosmic code, a quest that promises to redefine our expertise of existence itself. Whether exploring the depths of black holes, charting the trajectories of distant galaxies, or thinking of the nature of time and space, every discovery brings us towards unraveling the intricate tapestry of the universe. As we venture an edition into the cosmos, guided by curiosity and driven by means of a desire to understand its vastness and complexity, we are reminded of the phrases of Carl Sagan. Somewhere, something amazing is waiting to be recognized. This sentiment encapsulates the essence of clinical exploration, an ongoing adventure of discovery, wonder, and enlightenment that keeps to encourage generations of scientists and thinkers alike. In the words of Albert Einstein, the maximum beautiful factor we can enjoy is the mysterious. It is the supply of all proper art and technology. As we confront the mysteries of the universe, we're invited to embrace uncertainty, to assignment our assumptions, and to our seeking new perspectives that enlarge our expertise of the cosmos and ourselves. Therefore, the exploration of the cosmos isn't always merely a scientific enterprise but a profound human quest for knowledge and meaning. It is a journey that transcends the limits of area and time, inviting us to contemplate our area within the grand tapestry of lifestyles.